Alright, so this video we'll be discussing the May-June 2025 paper 5.3, which is the Probability and Statistics 1 paper. And let's start with question number 1. Okay, we are given some information here. We are having the 40 values of the x, and then the summary value for summation x minus k is this value. Summation x minus k squared is this one, where k is a constant. We are given the mean is 124. For these 40 values, then they want us to find out the value of the k. Okay, when you are looking at this question, right, we are having the coding summary. That means we are having the value for summation x minus k and also summation x minus k squared. When we are having this kind of coding data, basically when we want to find the mean and also the variance, there's a formula that you need to follow. To get the original mean for the x, from the coding data, basically it is summation of x minus a divided by n. You need to add back the a so that you can get the original mean. And then for the variance, the formula will be summation of x minus a squared divided by n, then minus the summation of x minus a divided by n and the whole thing squared. Okay, so these are two general formula to find the mean and also the variance by using the coding data, right? And these two formula are not provided in the formula booklet, so please make sure you remember it correctly so that you can apply in the exam. Right, so let's come back to this question here. They are given us the value of the mean, which is 124, and find the value of the k. Therefore, I want to use the mean formula here. Okay, so mean formula is mean is equals to summation of x minus k in this case, right? Then divided by n plus k. What's the value of the mean? 124. Okay, what is the summation of x minus k? It is given 836. What's the value for the n? You're having 40 values of the x, therefore the n equals to 40. And from here, very easily, you can get the value of the k. By right, you should get the k value, which is equals to 103.1. Okay, then let's proceed to the part B. For part B, they want us to find the standard deviation of these 40 values of the x. Alright, and we need to apply this formula, the variance formula, and you just put a square root to it so that it become the standard deviation, right? Okay, so let us bring it here. Alright, so to get the standard deviation, I need to have the square root. So standard deviation equals to the square root of summation of x minus a squared, or summation of x minus k squared. So where's the summation of x minus k squared? So this is what we have. 25410.8. Okay, so we are having 25410.8 divided by the n, which is the 40, minus summation of a, again, summation of x minus a again, or summation of x minus k, which is this one, 836, divided by 40, then you square it. Then you take the square root for the whole thing. Try to press calculator and help you. By right, you should be getting a very long answer, which is 14.08758319. Okay, of course, we cannot keep our answer like this, right? Therefore, you have to keep your answer correct to 3 significant figure where it should be 14.1. Alright, yeah, so this is how we solve. Okay, question number 2. In a large college, the students who study science have to study exactly one of art or drama or music. So from the science students, it is a large college. So we're having a group of science students. If you study science, you have to take either exactly one of these three subjects, right? Art or drama or music. So 20% study art, 45% study drama, and also 35% study music. So the 3 students are selected at random from the students who study science. We select 3 students, find the probability that at least one of these students study drama. Okay, so if you have a look for the structure of the question, right, we are having 3 students being selected, and then we are interested to know at least one of the students something happened to them. Again, this structure belongs to binomial distribution. Okay, so for binomial and geometric distribution in the exam, they won't give you the keyword like usually. You need to identify the structure of the question, also the pattern, to know that it is belongs to binomial or geometric. Okay, yeah, so for this kind of structure, it is belongs to binomial. So we know that X is binomial distributed where the number of students, we are interested in the number of students who study drama. We are having 3 students in total. Okay, and then what's the probability of a student that study drama? So the probability for study drama is 0.45. And for this part A, we are interested to find out the probability of X at least 1. At least 1 means greater or equals to the 1 of these students. Alright, so it should be X greater equals to 1. Okay, then just let us recall back again. If you are having the X with a binomial distribution, the parameter will be N and also the P, right? If I want to calculate the probability for X equals to a particular value R, so how can I find it out? It should be NCR, P power R, Q power M minus R. Okay, so let's come back to our question here. I'm interested for the probability of X greater equals to 1. So that means 1 must be included, right? Then the next integer will be X equals to 2. And also the next one will be X equals to 3. So you have to take X equals to 0 plus X equals to 1 plus X equals to X equals to 1 plus X equals to 2 plus X equals to 3. But the problem now is 1, 2, and 3, when you add them together, right, it is like longer. So to make the step shorter, I would choose to take 1 minus the probability of X equals to 0. Because 0 is excluded from our calculation here. Therefore, I have to take 1 minus X equals to 0, which is shorter in my opinion. Alright, so how to get the value for X equals to 0? Your N is a 3, so 3C0, P is 0.45. Power 0, 0.55 power 3. Then try to get the answer. Again, you should be getting a longer answer here. Then, of course, you have to cut it short into 3 significant figure where the answer should be 0.834. Okay, yeah, so this is the part A. Then let's continue to part B. Now I'm having 10 students are selected. Then more than 7 study art or music. So again, the structure is the same, where you're having 10 students at first, and we are interested to know more than 7 something happened to them. Alright, so maybe I can put it as a Y. So Y is still binomial distributed with the 10. What's the probability of the student who study art or music? Okay, so just now for drama is 45%. Therefore, art or music, a total of them will be 55%. So the P here will be 0.55. And we are interested to find the probability of Y greater than 7. More than means greater than, no equal sign. Okay, 7. If you're interested for Y greater than 7, that means I have to include Y equals to 8, Y equals to 9, and also Y equals to 10. So I will start from 8 first. So 10C8, 0.55 power 8, 0.45 power 2. Then 10C9, 0.55 power 9, 0.45 power 1. Then 10C10, 0.55 power 10, and also 0.45 power 0. Okay, then write out all the terms here, then try to get the answer using calculator. Okay, I want to keep my answer into 3 significant figure, and it should be 0.0996. Alright, yeah, so this is how we solve question. Okay, question number 3. There's a fair 6-sided dice, label 1, 2, 3, 4, 5, 6, is thrown repeatedly until a tree is obtained. Okay, highlight the phrase here, until something is obtained. So this kind of question belongs to the style where you repeating the experiment until the first success trial happen, or until the first success trial occur. So when you're having this structure of question, it belongs to geometric distribution. Okay, so the number of throw taken is denoted by the random variable x. Okay, so now let's recall again. What do we have for a geometric distribution, there's only one parameter in geometric distribution where it should be the p. Okay? And then the general formula for us to get the probability is, if let's say I'm having the first success occur at the R throw, the R experiment, okay, or the R trial, then that means the R minus 1 trial are failure, right? So it will be Q power R minus 1. Then multiply with the P. Okay? Then this is one of the general formula. Another formula that we are using quite frequently is, if let's say you are having x smaller equals to R, you can have a shortcut formula where it is equals to 1 minus Q power R. Okay, then for your information, 1 minus Q power R, this particular second formula here is not provided in the formula booklet. So if you want to use it, just make sure that you try to remember it before you go into the exam hall. Okay, so let's start with our question here. I know that this is a geometric distribution because you are looking for until a tree is obtained. So that means this is a geometric distribution. To put the P in the parameter as the parameter, the P will be the probability of obtaining a tree. So what is the probability of obtaining a tree? You're having a fair-sided dice, right? 6-sided dice, which is the fair one. So to get the tree will be 1 over 6. And they said the first success trial occur at the throw number 8. So that means the first 7 times they are all failure, and I'm having 5 over 6 power 7, which is R minus 1. Then the last time is a success, so it will be 1 over 6. Okay, then from that, you will get the answer, a long one, okay, 0.0465, 136, 0787. Then can you keep the answer like this? Cannot, right? So you have to cut it short into 3 significant figure, where it will be equals to 0.0465. Okay, so I think this one's still very straightforward. Then let's look for the second part. They are looking for the probability of x smaller than 9. Okay, so for this question, maybe you want to apply this particular formula here in what I listed down just now. But please take note, for this formula to be applied, you have to make sure that x is smaller or equals to the r. There must be an equal sign here. But for our question, we are having x smaller than 9, no equal sign. Therefore, we can adjust it a little bit so that it becomes the symbol with the equal sign. It can be written as x smaller equals to 8. Because geometric distribution is a discrete random variable, therefore all the value of x usually is an integer. So smaller than 9 also having the same meaning as x smaller equals to 8. And to calculate the probability here, you can just take the shortcut formula 1 minus q power r. So q will be 5 over 6. Then power r means power 8. Because x smaller equals to r, right? So r here is the 8. Okay, then again, same thing happen here. Try to press calculator. You will get a long value. And the final answer should be this. Okay, the final answer should be 0.767. Okay, then let's continue to part C. I think there's a part C here, right? Okay, find the probability that a tree is obtained for second time before the 6th throw. Okay, so for this question, it is a little bit longer because there are a few restrictions here. They said a tree is obtained for second time before the 6th throw. Maybe let us try to figure out the possible cases first, yeah? When they said tree is obtained for the second time before the 6th throw, second time, so second time means that the tree already occurred for 2 times. All right, what are the possible cases that I have? So maybe you can try to list out first. For the first case, maybe the first throw you get is a tree, and the second throw you also get a tree. Okay, so the first throw you get a tree, second throw you get a tree. It means that the tree is obtained for the second time before the 6th throw, because the second tree is here, and this second tree appear at the second throw. Understand why I said not? They're asking for before the 6th row. So second tree appear at the second row belongs to the case where it is get before the 6th row. Then what is the other possible case? So you might also have the second case here where you throw the dice for 3 times. Last time is the 3, and then the first 2 times here you get also 1 3. But the 3 can be in the first row, the 3 can be at the second row. So this case also belongs to a 3 is obtained for the second time before the 6th row. So the number of throw here is the 3. This one, the number of throw here is a 2. Okay, so you have 2 cases here already, yeah? Alright, then what else do I have? So maybe I put something here. This is a first case. First row is a 3, second row is a 3. Second case here is first 2 throw, you got only 1 3, and the second throw, the last one, you get a 3. Okay, then let's continue further. What else do I have? I might have, when I throw the throw the dice for 4 times, okay, then the last time, of course, is a 3, and this is the second 3. To make sure that this is a second 3, I need to know that for the first 3 throws here, there's also 1 3. Okay, then what else do I have? I will be having the next case, where when I throw it 5 times, the last time I get is a 3. Then after that, the first 4 times here, I also get 1 3. Okay, so you can see that this second 3, the 3 is obtained for the second time before the 6th row. Before the 6th row means that this is the 5th row. Okay, then my question is, should I include this or not? Should I include 1, 2, 3, 4, 5, 6, where my second 3 appear at the 6th row or not? Okay, the answer is not. This one shouldn't be included. It is because of the question requested for second 3 appear before the 6th row. But this, in this case, the second 3 here already appear on the 6th row. They are asking for before. Therefore, this case shouldn't be included in your calculation. Okay, so what do we have here is we are having 4 different cases here, where first case is you get 2 3 in 2 throw. Second case, you get 2 3, 2 times of 3 in 3 throws. Okay, but the last row must be the second 3, right? Then this one is the 4 time, and this one is the 5th row. Okay, then how can I calculate the probability for this one? For the first case, first row you get 3 is 1 over 6. Second row you also have a 3 is also 1 over 6. So you're having 1 over 36. Okay, then how about for the second row here? For the second case here. The second case here, you need to take note that the first 2 throw here, I got 1, 3. That means you have 1 success in the 2 throw. You can actually treat this first 2 throw as a binomial distribution, where it should be 2C1, 1 over 6 power 1. The success 3, success case is a 3. 3 means probability 1 over 6 is a 1. Then other score is another 5 power 6, or 5 over 6 power 1. This is the first 2 throw, and the third throw must be success, right? So I have to multiply it with 1 over 6. Then you get the answer for second case, where this is the part for the first 2 throw. You can treat this as a binomial distribution. Binomial distribution, 2 throw with 1 success trial. Okay, then for the third case, also the same. The first 3 throws here, you can also treat as a binomial distribution, where it should be B, then 3, and also 1 over 6. You have only 1 3 in the first 3 throw, therefore it should be 3C1, multiply with 1 over 6 power 1, then 5 over 6 power 2. Okay, then the last row, again, still 3, so it should be 1 over 6. And we do the same thing for the last case as well. We are having the first 4 throws with only 1 3. So the success trial is a 3. Then you're having 4 and also 1 over 6 for the first 4 throw here. You can treat as a binomial distribution. So I'm having 4C1, 1 over 6 power 1, and 5 over 6 power 3. Then the last row here must be a 3. Therefore, I have to multiply it with 1 over 6. Okay, so you'll be having the total or the sum for different cases here. So if you don't do any careless mistake, the second case here should be 5 over 108. The third case here should be 25 over 432. Then the last case here should be 125 over 1944. Okay, then after that, how can I get the final answer? So to get the final answer, you have to total all of them. Alright, so maybe I just write it here. So what's the total for all the possible cases here? So the total should be equals to 763 over 3888. Okay, or of course, if you want, you can cut it short into 3 significant figure, where it should be 0.196. Right, yeah. So this is how we solve question number 3. Question number 4. We are having 84 people attempt a particular puzzle. We are talking about the time. We record the time taken in minutes to complete the puzzle. Then this time are represented in the cumulative frequency graph below. So we are having a cumulative frequency graph here. Okay, for part A, use the graph to estimate how many people took between 4 and also 7.5 minutes to complete the puzzle. We have to estimate the value from the diagram. Let us start with the 4, followed by the 7.5. So where's the 4 minutes? 4 minutes is in the x-axis because they said x-axis is time in minutes, right? Therefore, I start from the 4, draw a line going up to the curve. Okay, then touch it and also try to reflect it and get the value of the graph. Okay, so try to read the value from the diagram. By right, you get the value 26. Okay, it depends on how you draw the line. By right, it is more or less like 26. Okay, then next one, I need to estimate the value from 7.5. So as 7.5 from the diagram, this is 7.5. Okay, try to draw a line going up to touch the curve also. In this case, I would strongly suggest you to use a ruler, yeah? Okay, then you try to draw the value up 7.5. Then reflect it to the left to read the value on the y-axis that you get. Okay, then if you try to read this particular value from the diagram, it should be around 69. So what does these two values mean? 26 and also 69. So 26 means that you are having 26 people spend less than 4 minutes. Okay, and after that, we are having 69 people use or spend less than 7.5 minutes. And to know, okay, the people that takes between 4 until 7.5, you have to take 69 minus 26. And by right, you will get 43 people who use between 4 minutes to 7.5 minutes to solve the puzzle. Okay, this is what we have for part A. Then let's continue to part B. For part B, they want us to draw box and whisker plot to summarize the information in the cumulative frequency curve. Alright, to get the box and whisker plot, I need 5 values here. The first one is the minimum. Okay, then we need Q1, we need Q2, we need Q3, and also the maximum value. All these value can be estimated, or we can get the value from the cumulative frequency curve. So let's have a look for the cumulative frequency curve here. What is the smallest value of the x-axis that I have? So this is the smallest value for x-axis, which is equals to 2, right? Okay, therefore I know that my minimum value is 2. Then how about for Q1? Our total frequency, total cumulative frequency or total frequency is equals to 84. Because you can see that the highest point here, the value of the y-axis is 84. To get Q1, you have to take 84 divided by the 4, which is equals to 21. Please estimate the value from 21. Usually, I would strongly suggest you, if you can, you try to label out clearly. This is 21. Then you want to estimate the value and see what is the value of the t. Okay, if you try to reflect it downwards to the x-axis and read the value, by right it should be 3 point, this is 2468, so it will be 3.7 more or less, right? Therefore I know that, oh, my Q1 is 3.7. Then how about for Q2? Okay, for Q2 you have to take 84 divided by 2 because it is in the center, is in middle, so you have to divide by 2. Therefore you have to estimate the value from 42. So again, try to label out clearly where is your 42, draw a line to touch the curve that they give us, then estimate the value of the x-axis. You reflect it downwards. Okay, so if you try to read the value here, it should be 4.9. Then your Q2 is 4.9. Right, then same thing happen for the third quadrant. You have to take 84 divided by 4, but you have to multiply with 3 because the third quadrant covers the first 75% of your whole data. Therefore, you use times 3 divided by 4, which is 75%. Okay, and this one you get 63. What does it mean? It means that you try to estimate the value from 63. Same thing, draw a line to touch the curve, then estimate the value from the x-axis. Okay, then in the exam you should use a ruler to try to draw the line clearly and also straight. Then you can check for the value. So what's the value here? To me, I think it should be 6.5. Okay, so when I write out in my summary here, it will be 6.5. Then lastly, let us have a look for the maximum point. Where did the graph stop? So the graph stopped at the last value for x, which is the trough. And I write it out as a trough here. Okay, therefore, when you want to draw any when you want to draw any stem and leaf plot, then this is the 5 numbers that you have to provide. You have to prepare before you can draw it out. Alright, then let us start with the drawing part. You need to make sure that you put in the scale and the ratio for the x-axis. Okay, I can't draw it very nicely. Let me draw it nicer. Put it larger first. Okay, this is my x-axis, and I know that it is actually time in minutes. Okay, then my smallest value start at 2 lah. The largest value is a 12. Okay, so it depends on how you want to use the scale. I'm actually following the scale using in the diagram. In the cumulative frequency curve, right, they already give us all the curve. So I'm using the same scale as what they use on top. Okay, then after that, I can start plotting all the number. The minimum value is a 2, so maybe I put the short line at a 2. After that, followed by 3.7, so I'm having 3. 3.7 should be somewhere here. Then 4.9. 5, then 4.9 should be somewhere here. Okay, then 6.5. 6.5 is this one. Then the last value is a 12. So 12, put the line as well. Now try to connect all the center 3 value Q1, Q2, Q3 by using the horizontal line, and eventually you will form a box like this. Okay, then form the whisker from the minimum and also the maximum value to the box. Yeah, so this is basically how our stem plot looks like. Okay, then please make sure always that you try to label the scale and also the x-axis clearly. Okay, yeah, so this is how we solve question number. Okay, so question number 5. We have bag A with 6 red marble, 5 blue, and 1 green. For B, you are having 5 red, 3 blue. Marble is chosen from A and placed in the bag B. Then I choose another marble from the B. Draw a tree diagram to represent this information given the probability of each branch. Right, so let's try to solve the first process first. For the first process, I take out a ball or a marble from the bag A. When you are taking something from bag A, right, you might have 3 possible outcomes where the marble that you get can be red color, it can be blue color, it can be green. If it is red color, then what is the probability? The total marble you have in bag A is 12. 6 plus 5 plus 1 is a 12. You are having 6 marbles there. Therefore, the probability of getting the red marble is 6 over 12. To get the blue color one would be 5 over 12. To get the green color is 1 over 12. Okay, so let's continue with the first case first. If let's say you try to imagine, you get the red marble from bag A. You put back into the bag B. Okay, then into the bag B, what is the possible marble that you will get from bag B if you take out 1 marble from that? Okay, so again, you need to recall back one more time. For this case, I'm considering first marble from A is red color. You put it back into the B. So that means in the bag B, your red color marble will plus 1 become 6. Okay, so 5 plus 1 is a 6. Blue marble remain the 3. What is the probability for you now to get the second marble, which is the red, from bag B? So you're having 6 red, right? So it will be 6 over 9. Then this one will be 3 over 9. Okay, why they will ask, maybe you ask why there's no green color one. It is because it is impossible for you to get the green color. If you have a look for bag B, you put bag A, a red color into the bag B. Is bag B having any green color marble here? Don't have, right? Therefore, you need to consider the probability of getting the green because it is equals to 0. Okay, that's the first case. Second case, imagine that the first marble that you get from bag A is a blue color. So you take out the blue color, you put it back into the bag B. The bag B also having red and also blue color only. Just that for now, you're having 4 blue color marble with 5 red. What is the probability for you to get the red marble now? So it is 5 over 9, right? 5 over 9. What happened to the blue color marble from bag B? So you're having 3 plus 1 is a 4. 4 over 9. Okay, then the last case, if the first marble you take from bag A is a green color, then what will happen if you want to continue to get a second marble from bag B? So in this case, you'll be having 3 cases, red, blue, and also green. Do you know why? It is because of when the first marble you take out is a green color, you put it back into the bag B, it is possible that later you'll get a green color marble. Therefore, you have to consider the green color case here. Okay, right, then try to imagine again. Just now, I got green color from bag A. I put it back into bag B. Now bag B is having 5 red, 3 blue, and also 1 green. So from here, total, there are still 9 marbles now. What is the probability for you to get the red color marble? So red color marble is a 5 out of the total. So 5 plus 3 plus 1 is a 9. Therefore, you will be having 5 over 9. How about the blue color? So you're having 3 blue marble, right? So 3 over 9. Then how about the green? So the green will be 1 green only in the back. So it will be 1 over 9. Okay, so this is basically how our scheme diagram look like. Alright, when you're trying to draw this in the exam, please make sure that you show all the branches clearly with the very clear probability on the branch. Alright, okay, then let's continue to part B. For part B, they want you to find the probability that both marble same color. Okay, so how to find both marbles same color? Both marbles same color. Okay, according to the tree diagram that we drew just now, There are a few possible cases here. Where is it? Let me have a look. Yeah, this one, right? Okay, both are same color. I might have first case where the first marble is a red, second marble is the red. So you multiply the probability along the branch. So 6 over 12 multiply with 6 over 9. Okay? 6 over 12 multiply with 6 over 9. This one gives you the cases where both of the marble are red color. And now if you try to find out the other possible cases, it will be both color are blue. Blue and also the, blue and also the blue, right? Okay, blue and also the blue, this one. Both are the same color, blue and blue. To get the probability, you multiply the probability along the branch. So 5 over 12 multiply with 4 over 9. 5 over 12 multiply with 4 over 9. Is that the third cases? Then you try to have a look here. It is possible for you to get a third case, right? Because it might be happen also when you're having first color is a green, second color is also a green. So this also belongs to the case where the two marbles are the same color. 1 over 12 multiply with 1 over 9. Okay, we are having 1 over 12 multiply with 1 over 9. Okay, so you have considered all the possible cases. Let's add up together and see you're able to get this one or not. 19 over 36. Okay, or you can make it into 3 significant figure, which is 0.528. Okay, yeah. So part B is like this. Then let's have a look for part C. Part C, find the probability that the marble chosen from bag A is blue, given that marble chosen from bag B is also blue. Okay, I want you to highlight the keyword given that. This tells you that it is a conditional probability. Okay, and usually the question will ask you like this, find something given that something already happened. Okay, let's say find event A given that B already happened. Okay, when you have this kind of structure of the question, it is telling you that you have to find out the conditional probability. And then what is the symbol for conditional probability? You have a slash one, okay? Then the event that happened first, write it on the right hand side of the slash. So as an example, when they say given that B, that means B already happened, therefore B had to put it here. Then they want to find event A, right? So for event A, you put it on the left hand side of the symbol. When you write out like this, it basically means that it is a conditional probability. And to solve it, you need to remember this formula. Conditional probability is A intersect with B divided by the probability of B. And this is a general formula. Okay, then let us start with what we have here in the context of the question. Now they say that I want to find the probability that marble chosen from bag A is blue. Okay, so you can write it like this, bag A, blue. Given that you must have a slash, right? Marble chosen from bag B is also blue, so you write bag B is also blue. Okay, so this is how we set up the conditional probability formula first. After that, apply into the calculation for the formula. A intersect B. A intersect with B, that means that I'm having bag A is a blue. Intersect with bag B is also a blue. Then divided by the probability of B. So probability of B means that we are interested to find out the bag B is a blue color. Okay, then let's start. For numerator, bag A is blue, intersect with bag B is blue. That means both are blue color. Why is the outcome that you're having both are blue color? That means this one blue and also blue. Calculate the probability along, multiply the probability along the branches, along the pathway. You're having 5 over 12 multiply with 4 over 9. So 5 over 12 multiply with 4 over 9. Then divided by, now they're asking for the back B is blue color. Okay, so go back to our tree diagram again. You ask yourself, where do you have the outcome where back B is blue color? So I think most of you can see, right? This is back B blue color, back B blue color, back B blue color. Okay, but the problem now is we cannot start our probability halfway from the tree diagram. Every time when you want to calculate the probability, it must be starting from the beginning. Okay, so you cannot tell me that, oh, the back B is blue, right? So I just add these three probability together. Cannot one, it is not correct. You have to start from beginning. To start from beginning, from here you can see three different pathways. The first one is first red, second is a blue. Okay, then the second case is first blue, second is also the blue. And the third case will be first is green, but the second is still a blue. So there are three different pathways here. All of them belongs to the back B is a blue color. Okay? Yeah. Therefore, to get the probability, you just need to multiply the probability for every single branch. So in the single branch, you multiply the probability to each other. 6 over 12 multiply with 3 over 9. Okay, so let us continue from here. 6 over 12 multiply with 3 over 9. Then what about the second case here? The second case here, you can see that it is purple color, 5 over 12, 4 over 9. Okay, so 5 over 12, 4 over 9. How about the third one? Okay, so for the third one, it will be 1 over 12 multiplied with 3 over 9. 1 over 12, 3 over 9. Okay, then just make sure that you don't do any careless mistake when pressing calculator. Numerator value is 5 over 27. Okay, then after that, for the denominator, it should be 41 over 108. Okay, so simplify this fraction. Eventually, answer should be 20 over 41. Or if you don't want, you can keep it to 3 significant figure, which is 0.488. Alright, yeah. And this is how we solve this question number 5. Okay, question number 6. There's a company sells bags of pasta. The mass of large bag of pasta is normally distributed. Highlight the keyword normally distributed. Mean is given, standard deviation is known. Okay, find the probability that the mass of pasta in the randomly chosen large bag is less than 2.65. Okay, I think this question is very obvious because you can see the keyword normally distributed. So it is normal distribution. So X is normally distributed with mean. Oh, sorry, I write wrongly. It should be the N, mean, normal, yeah. Mean is 2.50. Standard deviation is 0.12, but I have to put the variance here, right? So it should be 0.12 squared. We are interested to find the probability of X less than, smaller than, okay, so 2.65 kilogram. Since this is a normal distribution, to calculate the probability, I have to standardize it become Z, where I take the value of the X, 2.65, minus the mean, provided negative, that means minus 2.5, divided by the standard deviation. Standard deviation is 0.12. Okay, so to find the probability, of course, you have to try to change it become standard Z first, standard normal Z. After that, only you figure out the probability from the table. Okay, what is the value that I get now when I simplify? I get 1.25. To get the area of Z smaller than 1.25, just use the MF19 to help us. Okay, looking for 1.25. So where's 1.25? This is 1.25 if this one, 8944. Right, 1.25, this is 8944. Okay, then answer is 0.8944. Then for me, I will change it become 3 significant figure where it will become 0.894. Okay, yeah, so I think this question is quite straightforward. Then let's continue to part B. For part B, we are having 160 bags of pasta. Find the number of pasta where you should expect the mass of the pasta to be more than 1.65 standard deviation above the mean. What does it mean? That means the mass of pasta means X. More than means greater than. 1.65 standard deviation means 1.65 standard deviation above the mean. So 1.65 standard deviation above the mean means that you're having the mean and then you top up another 1.65 standard deviation. So in short, it means that it is a plus mu. Mu is the mean. Okay, and they want you to find out the number of pasta. Before we can do that, we need to find out the probability first. Okay, so again, from this sentence, this is how you convert the sentence into the symbol. And now you want to find the probability that X is more than 1.65 sigma plus mu first. All right, yeah. Okay, so now let's continue further. To find out the probability for this one, of course, you have to standardize it become Z, right? Okay, so how to standardize it become the Z? You take the value of the X. This is the original value for the X minus the mean divided by standard deviation. Agree? Okay, then when you try to simplify here, what do you get? You'll be having 1.65. What is the probability of Z greater than 1.65? You have to take 1 minus, find out the area from the table, looking for 1.65. 1.65 will be this one, 9505. Okay, then put it back to our step. 1 minus 0.9505. Then you get 0.0495, correct to 3 significant figure. Okay, so when you take 1 minus 0.9505, right, you already get a 3 significant figure answer. Okay, and now, is this a final answer? No, because for this question, they are not asking for probability, but they are asking for the number of bags for pasta. To calculate the number of pasta, you have to take the total amount of pasta that you have. So you're having 160 bags, multiply with the probability of 0.0495. Okay, then from here, if you try to press calculator, you should get the decimal number, which is, where is it? Oh, I didn't multiply it out. Okay, so you have to take 0 multiply with, so you have to take 160 multiply with 0.0495. Okay, then by right you have 7.92 lah. But of course, the number of bags of pasta should be the integer, right? So 7.92, I will put it as 8 bags. That means you're having 8 bags of pasta. Okay, and usually for this kind of question, in the marking scheme, they will accept both. Either you round up the value into the next integer or round down the value to the previous integer. But no matter how, they will accept either one. Okay, they will accept both. When you want to write the answer, just write out one only. One will do. So usually for me, I will just decide by looking at the decimal number. If let's say the 9 is closer to the next integer, then I will round up. If let's say the number after the decimal is maybe 4 or 3, then I will just round up. Okay? Right, so for this question, we are having 8 pasta that is having more than 1.65 standard deviation above the mean. Alright, yeah, then let's continue further for part C. Now we are having the small bags of pasta. They are still normally distributed. Mean and standard deviation now I don't know. So I have to set up the question to find out the mean and also standard deviation. Right, from the question you can see the value of mu and also the value of standard deviation. Then to set up the equation, I need information to start with. Yeah, so the information is provided in the question. 77% of the bags has the mass greater than 1.26. For this particular sentence, I know that if I say my x, I assume that now x is the small bag of pasta, okay? So x greater than 1.26, the probability or the percentage is 0.77. The percentage is 77%. Change it become the probability. It should be 0.77. Again, since we know that it is normally distributed, therefore I have to standardize it. So I'm having 1.26 minus the mean. So I don't know what is the mean. Divided by standard deviation. I also don't know what is the standard deviation. Then it is equals to 0.77. Then now let us try to draw out a diagram to see what is the area for my particular equation here. Z greater than something equals to a large area. Therefore, I should know that my Z should be on the left hand side here. Okay, I need to find what is the value of the Z for this one so that it fulfills my equation where Z greater than a particular value, the area is 0.77. Okay, right, then to find out this particular value of the Z, you need to read the normal distribution table backward because this is the probability provided. This is the value of the Z. Okay, according to what we have in the table, these are the probability. All the value of Z is outside. So you have to find out, use the value inside to find out the value Z outside. Let's look for 0.77. Where's the 77 here? The number closer to 77 but closer to the 77, 0.77, but which is smaller than it is this one, 7673. For 7673, you need to add a 27 to get 7700. Right? Is there any 27 at the back? At the same row, yes. So if you try to read out the value of Z that you get should be 0.739. Okay, I go back to my step here. This Z, the question mark here should be 0.739. Then according to this particular diagram that you draw just now, right? This value 739, 0.739, should it be positive or negative? You need to know that in a standard Z variable, the mean is a 0. Okay, then you're having the line here, which is before the 0. Therefore, your value of Z will be negative 0.739. And this value of Z, same as this one. So I try to form first equation by using this information. 1.26 minus the mean divided by standard deviation is equals to negative 0.739. I try to rearrange everything, then I get my first equation here. Okay, then of course I can't get the answer here, right? For first equation, because I only have one equation, so you have to form second equation. Then you can solve them simultaneously to get the answer. How can I get the equation for second part? Then let's have a look for the question one more time. Now they say that 44% less than 1.35 kilogram. Then I can form second equation from here. Less than 1.35 kilogram, x smaller than 1.35, 44% means 0.44. Same thing happen here. First step, you have to standardize it first. Okay, second step, you try to draw a diagram for this graph. I have Z smaller, then that area is a small area. Smaller means shade the left hand side, and this area is a small area, 0.44. And this is the value of Z that you want to find. Okay, then again, to find the value of the Z, you have to use the area to find out. But 0.44 is a small area, so you can't get the answer by using a small area. You have to use the complement area to get the Z. Take 1 minus 0.44, you'll get 0.56. So to get the value of the Z, I have to refer 0.56 instead of 0.44. Because if you try to have a look for the question here, there's no 0.44 in the probability area, the probability part. Okay, then now we are looking for 0.56. Okay. Alright, so what is the value for 0.56? Looking for the probability 0.56. I think this is the closer one, 0.5596. Then you need to add the 4 so that you can get 5600. Then you can get the 0.56, right? Okay, yeah. So 5596, I have to add a 4. Is there any 4 at the back? Yes. Then if you try to read out the value of the Z, you will get 0.151. Okay, then for the Z here, this is 0.151. But is this value a positive value or a negative value? So again, try to refer to your diagram one more time. The center line is a 0. This Z is before the 0. Therefore, it should be a negative value. So negative 0.5151. Compare the value of the Z in your equation here and also the value of the Z that you get. This is what you have, 1.35 minus the mu divided by standard deviation is equals to negative 0.151. Okay, I try to rephrase the equation one more time. And I get the second equation here. I think the next steps, the next few steps will be very easy to get the value for mu and also the sigma. You just need to solve the equation simultaneously. So I like 1 equals to 2. Then what do I get here is I'm having this 1.26 is equals to 1.35. Okay, then after that I try to solve it. I will get 0.588 sigma equals to 0.09. And from here, what is the sigma that I get? I try to keep it in the fraction form because later I want to use it to calculate the mean. So the fraction form should be 15 over 98. Okay, then 3 significant figure answer will be 0.153. This is my sigma. Then don't forget to find out the mean. Okay, to find the mean, I just need to substitute my sigma into the mean equation. It can be anyone. It can be equation number 1. It can be equation number 2. Okay, but just for your information, when I want to find the mean, right, the value of the sigma that I use must be always the original data, which is a long value or the original fraction. So I'm using 15 over 98 here. Okay, then simplify the answer. By right, the mean should be 1.37 correct to 3 significant figure. Okay, so just a small reminder. Every time when you want to use one of the answer and substitute into the equation and get the final answer for the other variable, right? Always remember that this particular answer here must be the original value. Please don't use 0.153 and substitute it here. Your final answer might be a bit different. Okay, all right. So always remember that, yeah. If you want to use any value to substitute it to get the next answer or next part of the value and whatsoever, your value here must be always the original value, preferable the fraction form, okay? Yeah, so this is what you have for the 6C. And we'll discuss question 7 later. Alright, so this is the last question for this paper, question number 7. We have a set of friends with 7 men and also 4 women. 3 of the men are brothers, Ali, Ben, and Charlie. Find the number of different arrangement. Highlight the keyword arrangement here. So this word tells you that it is a permutation where you might involve the factorial and also NPR in your calculation. Okay, so we're having the number of different arrangement for the 7 men in a line. We only focus on the 7 men, which Ali and Ben do not stand next to each other. Okay, when I want to separate maybe the 2 items or 2 people or whatsoever, I always arrange them lastly. So first of all, I'm having, okay, Ali, Ben, and Charlie, they are brothers and brothers, right? So I have to include Charlie, then man number 1, man number 2, man number 3, man number 4, and also man number 5. Is it? Wait, we are having 7 men in total. So 1, 2, 3, 4, 5, 6. Oh, cannot. I have until man number 4 only. Okay. So man 1, 2, 3, 4 with Charlie. Then Ali and Ben. So Ali, Ben, Charlie with these 4 men. Total, there are 7 men. I want to arrange them in the line. But I exclude Ben and Ali first because they must be separated. So I arrange the 5 person here first. Arrange 5 person. The step will be 5 factorial. Okay, then after that, I want to slot in Ben and Ali into the spaces available among them. This one. How many spaces available here? So 1, 2, 3, 4, 5, 6. 6 spaces available. And you want to place 2 person inside. Therefore, it should be 6B2. Okay, then answer should be 3,600. Right, continue to part B. Find the number of different arrangement. Highlight the keyword arrangement again. 7 men and 4 women in a line, where all the men stand together, all the women stand together. Okay, this is a case where there are some items must be always together. So when they must be always together, yeah, what we do is that we group them as one big group. We bundle them as one unit, I would say. Okay, so I'm having Ali, Ben, Charlie with the 4 men. I put them in one group. So I treat this whole unit as one unit. Then I have women, 4 women, 1, 2, 3, and also 4. And I also put them as one group because the women must be always together as well. Okay, so first of all, we arrange the bigger group first, the overall group. Overall group, how many items do I have? 1 item and 2 items. So I'm having 2 factorial. After that, I have to consider the arrangement within the group. So for these 7 men in the group, they can exchange their position between them, right, within them. So 7 men means 7 factorial. Same thing happened for the women. You are having 4 women in the group, right? You can also, you need to consider the arrangement of the women within the group. So there are 4 women here. The arrangement will be 4 factorial. Okay? Then just simplify them. By right, you'll be having 2, 4, 1, 9, 2, 0. Right, so this is part B. Then let's continue to part C. Now they're asking how many different ways can 7 men and 4 women be divided into a group of 6, 3, and 2 if there's no restriction. So I just want to separate them into 3 different groups. So very easy. When you want to divide them into the groups, you select them group by group. Okay, I'm having 11 person in total. I want to select 6 of them and put it in the first group first. So it'll be 11C6. Okay, then after that, you multiply. For second group, how many person you still have? You left only 5%, right? So from the remaining 5%, you want to choose 3 of them and form the second group. Then the remaining 2 person, you want to choose all of them to form a group of 2. So multiply them up, you'll be having 4, 6, 2, 0. Okay? Yeah, so without restriction means that you separate into the group, but you're not looking at their gender. You just select them randomly, right? Then let's continue to part D. Now, they say the 7 men and 4 women are divided into a group of 6, 3, and also the 2. Find the probability that Ali, Ben, and Charlie are all in the same group. Okay, so this is a restriction, same group restriction. Let's think about what are the cases that's possible for 3 of them are in the same group. Okay, so I have a group of 6. Basically, I have 3 types of group. So I have 6-person group, I have a 3-person group, I have a 2-person group. Okay, so for case number 1, I can assume that Ali, Ben, and also Charlie are all in the 6-person group. Okay, then what is remaining? So for the 6-person group, if let's say 3 of them are in the same group already, then there are remaining 3 space available for the 6th group, right? Then the 3 here, you're having 3 lah. The person, the 2-group person, the 2-person group is having 2, still empty 2. This one empty 3, this one empty 3. I have another case where if let's say Ali, Ben, and Charlie, right, all of them are in the 3rd group, 3-person group. So 1, 2, 3, 4, 5, 6. Then I'm having 3-person group here. ABC is under the 3-person group. Okay, then the 2-person group still empty with 2. Okay, these are the 2 possible cases that might happen if let's say Ali, Ben, and Charlie must be in the same group. They cannot be in the 3rd group because 3rd group has only 2 persons available. Alright. Okay, so first of all, I try to list out all the possible cases first. Then now they're asking for the probability, right? Okay, we have to calculate the probability, yeah? First of all, let's choose them first. Choose the member and form the group first. Okay, for case number 1, ABC already in the first group. How many persons you still have, yeah? They are having 11 in total. 3 already in the group. So I just left only 8%. So for the 8%, I want to choose 3 of them and put it in this part. So it will be 8C3. Then how about the remaining person? After you choose the 3% out already, you still have 5%, right? So for the remaining 5%, you want to choose them and put it into the group here, the 3-person group. So it will be 5C3. Then the remaining 2%, you'll be having 2C2. Okay, but they're asking for probability. This is a number of combination. For the probability, you have to divide the total selection without restriction. Do you feel that this sounds very familiar? We already find the answer just now. The total number of selection without restriction. The answer is 4620. Okay, so you have 4620. And you get an answer here. By right, your answer for this one should be 4/33. Then how about for the second case here? So for the second case, you also already placed Ali, Ben, and Charlie in the 3-person group. Okay, so I left only 8% in total. I want to choose this 8%, 6% from this 8 to form the group of 6. So it will be 8C6. Then remaining 2%, you want to choose them, put it into the 3rd group, which is 2C2. Then divided by 4620 as well. Then what do I get here? I'll get 1/165. Okay, so after you successfully found the probability for 2 cases here, then the final answer will be the total of them. So what is the total probability? It will be equals to 7/55. Okay, or if you want, you can cut it short into 3 significant figure answer, which is 0.127. Alright, yeah, so this is basically how we solve this question, and this is the end of the video. Thank you very much for watching the